Hello and welcome everyone. If you follow my channel for quite some time, you already know that like a couple of years ago I started to work on integration of different test related capabilities into Geyser IDE to make it easier to run and rerun test suites from inside of Emacs. And later I realized that probably the API provided by Geyser is not perfect for this kind of job, and started a development of Arei and Arei's IDE. And I ported the capabilities that I already tried to implement in Geyser for test execution, re-execution, and all that stuff to Arei and Arei's. And after that, I found out that Surface 64 is a bit lacking, both in terms of functionality. There are some missing pieces or questionably implemented things, and also the specification itself is not very clear and not complete. And you can read all the details about Surface 64 in a great article by Thomas Wolf. I guess this one, State of Surface 64. Right here. And you can find a lot of details about what is wrong with current Surface 64. And unfortunately, there is no other alternatives to this library that are widespread, well specified, and so on. So, the idea behind this project that I am working on right now is to provide such a library which has a good specification, which has a very nice implementation, and also which integrates into IDE and very handy to use in your REPL-driven development without restarting the whole application. Because most of the tests written for Scheme projects are intended to run from CLI and like completely restart the whole system every time, which is not very handy when you want to update the definition of only one function. So this is the path we went through to get to the current point. And of course, implementing a library which is quite fundamental and potentially will be used in many Scheme projects can be a time-consuming task. And that is why I tried to find some funding for this project. And luckily, there is an organization called NLnet, which previously was a Unix user group which does a lot for making internet in Netherlands and probably in European Union in general. And later they like slightly changed their direction and do a lot of other things. And right now, one of the things that they're doing is providing grants for different free and open source software projects important for human society and internet in particular. And they have zero grants for supporting next generation internet. And because Scheme is used in many projects, for example in Geeks, in Sprightly Goblins, and many other related to reproducible builds, distributed systems, and so on, it is like a very important part of the internet already. And luckily, our application for the project for test library for Scheme was accepted by NLnet, and this project will be not only baked by some experience of some scheme developers, but also by funding provided by NLnet and I guess European Commission, who supports this project. So, I'm Andrew Tropin. I work on operating systems and programming languages and do a lot of free and open source software along the way. And today we talk about suitbl, a scheme testing library that is supported by very cool guys from NLnet. And we will start from a plan on the implementation of this library and the way of introducing it into ecosystem, because the library implemented on its own won't be very useful if nobody knows about it. So we will need not only to implement the library, but also write a specification and somehow spread this library and adopt it inside scheme ecosystem and Guile ecosystem in particular. The first part of the plan is to make a proof of concept release. This includes the initial library API that will allow to do all necessary things, to run tests in the REPL, to run tests without test runner, to run tests with test runner, to combine multiple tests into test suites and do all that usual stuff that you expect from testing library. After that, it would be cool to integrate it straight into IDE, so you can run it much easier and restart particular test suites for every change you do with your eval comments. And of course, after we settled a bit on the API and we see that it's already working and have a quite good understanding of how it will look like, we can initiate a SRFI, because the SRFI is quite a long process. For people who are not familiar, it's like RFC, request for comments, but it's probably scheme request for implementation. It's a formal process for making a well-specified library for scheme, which should be approved by some community members and will be published on a SRFI list. And every SRFI has a number, so you can reference whatever SRFI you're talking about, and you will be able to read the specification and see the reference implementations. And of course, you can include different SRFIs in different scheme distributions. And of course, we will package it for gigs, because we have expertise with gigs package manager, and it's a very widespread tool for managing Guile dependencies, so it's very obvious target for us. After that, after proof of concept release, we will be already use this library and have a fun with it and have a proper testing of our projects, but we would like to go further. We would like to provide additional tooling for running tests for the whole project, and not only running but also exploring what tests are available in the current project. We would like to add a meta information to those tests, so we can make precise queries of what types of tests we want to run right now. Either it integration test or just unit tests, or a particular test for a particular model or function, and something like this. Maybe we would like to skip some slow tests or to run only, I don't know, tests which has a tag funny. And all that will make it very flexible for developer to adjust the workflow to a particular use case. And we would work on advanced test runners that will support those capabilities, and probably would also support parallel test execution for running tests which are independent from each other and can be like executed in parallel, which will speed up the rerun of the tests. So you can evaluate a new function definition and see that all other parts of your system still works the way you expected, or at least the way you tested it. After that, we will go to, I would say, very basic thing that is probably expected from the library is CLI test runner, which allows to run tests without having an REPL server or running application or anything else, which is sometimes useful to have for your local development when you don't want to set up your development environment or don't want to start your ID. You just can type make check and it will call the CLI test runner and will do all the stuff. And also it's very useful for continuous integration when you want to run your tests on some CI infrastructure. When you push new commits or do something else, it will be automatically executed and checked that your changes didn't break any existing tests. Probably there are some other use cases for it, but you know, those are primary and worth mentioning. And of course, we will do some documentation, also maybe some additional packaging and updating existing packages, and kind of public release. Because at this point of time, I think we will be ready to provide a very stable API, which won't break, which will likely won't break in the future. And we will be able already to share it with a wider audience because we will be more sure that we won't need to introduce any breaking changes in the workflows. And the next step will be the standardization of the library itself and the tooling it provides. We will work on JUnit compatibility because JUnit XML is very widespread format in all kind of tools, including different CI tools, for example Jenkins and Circle CI, and probably much more. We will provide a surface specification, and I hope we get it approved and accepted. We also plan to do an independent R7RS compatible implementation that we can first of all test against, and the second of all to use in a different schema implementation, because the current library is definitely developed in Guile language and targeted for Guile language first, but we would like to our work to be, you know, useful in a wider community rather than Guile. So I hope our work will benefit the whole scheme community, not only Guile geeks and Spriteleys. And of course we will do some adjustment to our library to make it more R7RS compatible if it's possible, and we will do a release of SRFI conforming version of our library. And after this work done, we will start introducing the library into ecosystem. It would be cool to include the SRFI in the Guile distribution, so it's available out of the box and doesn't require any additional steps to get it into your Guile project. we will rewrite tests for some projects, for example for Arei, which is obvious choice because we're maintaining Arei project and know all the details, but also it would be cool to work on rewriting tests for some popular other Guile projects like Fibers, Guile Hood, or maybe Guile JSON, or maybe even Geeks, but we'll see. But definitely we need to do some work for popularizing and like spreading the library into the Scheme and Guile community. And that's basically the whole plan of conquering the testing world of Scheme. And I hope we achieve it in like maybe 8 months or something around. If you do it earlier, it would be perfect. If you do it later, it will be still okay. But I hope we will just do it someday. Okay, that's basically about our plan. Now we can finish our theoretical introduction and do some live coding and think about the design of the project, about architecture of our library and its API. I already drafted like a few lines of code, like 250 lines of code, and it's still simple. Like I already have almost all necessary entities for testing, and the library still doesn't look too scary. Moreover, the API for the library also looks very neat. This is like the almost complete example of the library usage. The ideas we have in this library. First of all, we have a very important macro is, which is assert macro, which just take an expression and tests it. It tests it against what? Against true. If the value is true, the assert consider it passed. If the value is different, if it's some kind of false, then test is not test. The assert consider it failed. It works the same way as it works the if special form. You can use is assert on its own like this, and you can see that it expected that this value will return, this expression will return true, but it didn't. And it can have two forms. First one is just having like a particular form, and the second one having a particular form which contains a predicate in the beginning. For example, this one is assert which checks if true is a true value, or if 123 is a true value. They both are. And you can see that both of them passed the assert. And another option is having a bit more complicated expression which contains a predicate at the beginning. And in this case, we will be able to make a bit more meaningful message knowing the type of predicate. For example, for else set, we can show on fail, not the hard-coded message which just adds not at the beginning of the form, but we can say that the difference between those two sets is following, and show set difference for two sets, which will be much handier to understand of what values are present in one set and not present in another, or vice versa. Yep, that's basically everything that we need to know about is. Now, let's talk about the structure of the test. The test can contain asserts, and the test case is an entity which can contain a few asserts. So it's a group of asserts which related to some particular functionality. So it's just a logical unit of composition, I would say. And we can have test suites which can contain a few test cases. The assert on its own can be also considered a test case, as a test case, if it's not wrapped into other test case. And test suites can contain other test suites. So you can have like a few nested test suites. And it is already an implementation detail, but test suites is a lambda. So it's a basic function that you can call. And that means that you can easily compose a few test suites by just creating another test suite and calling nested test suites inside it, like we did here. You can see that we call the lambda returned by test suite and another nested test suite which is called inside the outer one, and all of those are combined into one more test suite. And defined test suite is basically as usual test suite, but you provide a name of the function like this. And it is written in some variable and available for test runner, which can print a very pretty results and show the structure of your test cases. Why we have so many different entities like asserts, test cases, test suites? Because it makes, first of all, easier to reason about the structure of your tests and how they relate to each other, how different parts of your test infrastructure relates to each other. And also it's very similar to how JUnit XML format is structured. And it will be really easy to map this kind of structure to JUnit XML. Also, we will need to provide some checks. For example, the test case can be nested into another test case, and only test suites can be nested in each other. And test suite can't be nested into test case. That's also should be checked. But other than that, the structure is quite simple. We don't go simpler because it will be harder to understand what entity is in front of us. For example, here we have a clear distinguish between asserts, test cases, and test suites, and we see that test suites is nested into another test suite, and only implicit thing here is a test case which we can create on top of is implicitly, on top of is assert. But other than that, the structure is very straightforward, and we have all the steps. If we have, only assert, we know that we don't have a test suite and test case. That means that we can come up with some default values for those things, and we can still provide this, structure, but it will just contain one unnamed test case and one unnamed test suite. But the structure will be the same between different use cases. That means that we will be able to apply all the tooling in the same way. Okay, let's actually continue implementing some cool stuff in this library. Let's first of all start from test case. Let's say that the default value for test case is just a dynamic variable which we will change during the execution of the tests. We will set it to false to make assert macro is to be aware that it's not wrapped into test case yet, and that means that assert macro itself should care about creating unnamed test case around itself, so the test runner get all the events related to the whole testing chain. And test pass is actually the list that contains all the nested test suites. Okay, we have a test case and we have a test pass, which is very good. And we can see how test case works. It's just a macro which changes the value of test case to the description. Here I have a to-do which says that we want to notify test runner that the current test case contains 0 expressions containing is assert. Let's write a test for this. Define test suite which called test case test, and it will be test case 0 asserts test case. Of course, we need to think about if it makes sense to create test cases which contain 0 asserts. I think it makes sense. For example, if we don't have an implementation for test case, but we already created it, not yet implemented. We can handle it somehow this use case and notifying test runner that there is no asserts. And how we do it? The lifetime of test runners should be defined clear, because we don't have any lifetime cycle of test runners yet. For now, we don't even create them, I guess. Why we need a test runner? Because this is the mutable entity which keeps track of everything that is happening to our tests, right? Because we can't get this information from somewhere else. Let's see a test case implementation. Here at the test case, we've parameterized test case asterisk variable, and now we need to check that there are any asserts in the expressions. But how we do it? We can't search through the code inside the body of test case, because is macro can be wrapped into another macro, and it won't be clear that we don't have is, because the is can appear on later macro expansion stages, and also is can be nested into begin form, for example, and it will also make it's hard to check if we can contain any assert forms. That is why what we can do, first of all, we can get a number of test cases of asserts before the execution of the test case, and get the number of asserts executed after body of test case, and we can compare them. And if it's a 0, we will notify our test runner that 0 asserts was executed in this test case. Compare them, notify if 0 asserts but we need to keep in mind that tests can be executed in parallel, and the unit of parallel execution should be a test case, I guess. This is another point where having those entities are important, because if we have only asserts, that means that the whole operation should be executed inside assert, all the related operation which can do some mutable things. And if we have a few asserts, we will be able to run them parallel only if the body of the assert is executed in one step and doesn't depend on any others. But unfortunately, our the scheme language is not a pure functional language, and we can't rely on the property that all the consecutive asserts will be independent and will be pure, because they definitely can mutate some state, which means that we can't rely on only a notion of asserts, and we would like to something to group a list of asserts into a test case. And the test case potentially can be executed in parallel. But for this, our test case would need to be a lambda, but it's not the case here. Our test case is not a lambda. It's just an expression which sets a test case variable for now. And making it a lambda will make it necessary to wrap every test case into additional pair of parentheses. And also, it will be hard to distinguish between test suite and test case. That's why I think that test case should still remain the macro, and test suite will be a unit of testing that we can execute in parallel. You can see that we don't have defined test case macro, and this is for a reason. We have only defined test suite, because test case will immediately evaluate the expression. That means that it will happen in compile time, not in the runtime. So we don't have a way to defer the computation, and we defer the computation only by wrapping a test suite into lambda and running it later with a test runner or with our IDE tooling or somehow else. Okay, let's keep this structure for now, and let's think, I guess, about test runner lifecycle. And what operations we can do with test runner. Test runner. You know what? I would like to attach my tablet to the laptop and to draw all the things and share the screen of the tablet with you, so you can think, you can see what I draw. But I don't have any spare USB ports to do so. Unfortunately. Okay, let's reason about it in the text. test runner will contain some information for sure. Let's start a comment. Contains information. What kind of information? The structure. The structure. Suit 3, case 1, assert 1. The structure. Of course, for every assert, it will contain the result. For every case, the result and time spent. Summary. Number of asserts, number of fails and successes, total time spent. Let's find the link somewhere here. I guess I had it. Oh, okay, right here. I have a link which shows the structure of JUnit tests. Actually, we don't even need to capture the information for particular asset. Also, I guess, contains it would be very useful to capture std out and std error for test runner, not to interleave the output of test runner with the output of the code and have them separate. And the test runner will decide how to print it. We can print std out and std in the body of the test case after the cert is executed or after the whole test case is executed. Or maybe we can even have two separate output streams, and we can have two separate windows in IDE. In one we will see the output of the code executed, and another one which will contain only the information about test cases. Similar for test suite. Properties. Not very interesting. I'm more interested if it's possible to have something to fail without having a test case. Probably no. We always have a test case. The reason I'm asking is because I still not sure if we need test cases, or we can use a test suite, the last test suite as a test case. Probably no, because it will screw up a bit the structure. Hello. I have a doggo under my door. I don't need, no, I think I need to spend the time with this doggo. But probably later, a bit later, my friend. It's not my doggo, it's like a local dog, but they're very nice. They're very polite and they bite very gently. You can put the whole arm in their mouth and they will be like without like actually raising with their teeth. I don't know if it's like a right behavior that the dogs like grabbing your arm with their teeth, but at least they do it really gentle. I would like to have one. Sorry for like a bit off topic, but I really like dogs. If I had like some stationary point on this planet where I spend like most of my time, I would like to have a dog here. Test case, test case, test case. Assertions 3. Okay. Okay. For concurrent viewers. My dear viewers, do you have any questions so far? I'm just, thinking out loud and writing probably not very how you would say, the stuff that doesn't make too much sense for a person who just coming accidentally to the stream. Similar for test suite. Okay, test runner contains information. Life cycle. We can either create a test runner and pass it a list of tests to execute, or asserts test cases and test suites can instantiate some default test runner. Begin suite. It will be some communication between test suites, asserts and cases with test runner. And what we can do, we can begin suite, we can begin case, we can begin assert. Also the information time spent, and begin assert and assert, not end assert. It will be end case, definitely it will be end suite. It will be end suite, fail assert, pass assert. Or we can say that it's and assert, but it pass or fail. It will accept some argument in it. Begin case time. I just think about the information that we need to pass to those events. Time. Okay, now we don't need to hardcode any information inside test case. Now, previously, do you remember that I said that we need to get number of asserts, blah blah blah? We don't actually need it. It will be done by our test runner. It will be definitely, and only thing that we need to do to call begin case, test case, and test case. And our test runner will decide if it needs to summarize the information about the number of asserts executed during this case. Okay, we actually do what is written here. The only question is to how communicate events with test runner. Is test runner is a record, or test runner is a lambda function which contains some stuff baked into the closure of the lambda? Go to model surface 64. How about going into the implementation of SRFI and taking a look at how they implement test runners. Test runner Arei set. They have test runner current runner factory. Oh, this is interesting. This one is interesting. Let's see. Test case. It returns unnamed. Where we have it defined. Let's go to definition. Test case. Okay, and if we do test case some value, Okay, we can set the value of parameters like this. This one can be useful for development. For example, for running, particular asserts with particular values. And those dynamic variables should be private, I guess. Because you never need to set a test case manually. Okay, anyway, let's talk a bit about test runner. We somehow got current test runner, right? Oh, I already created such parameter. Okay, that's fine. Current test runner. And on this current test runner we can operate somehow. We can send some messages to it. Message test runner, like this. Message test runner, and here is a message, like type test begin, suit begin, time current time. By the way, how to get, oh, there's a such function as current time. Cool, very nice. If it works. No, it doesn't work. Or maybe it's just a not very smart parser. Okay, it's just a parser. Okay, that's very good. What can I say? This interface seems viable. Do I want a current test runner to be accessible by user? Don't think so. But define get current test runner can actually return current test runner. $sign at the beginning of the variable usually means that it's some kind of private variable, like internal one for this module, and test pass and test cases also to make them private. Oops. And it will make it possible to make our test runner asynchronous, right? We created a test runner gave a test runner a test to run, and a callback or something like this. Okay, making a synchronous test runner is a bit trickier. But anyway, this message structure seems okay to me right now. I guess I will need to spend a bit time looking in how to implement asynchronous test runners and how to better it will be to implement look at what I understood right now. We can have message test runner get current test runner type run tests, and here test suits list of tests. We create an entity, a test runner, which can be some kind of object, which also contains a reference to a thread created along this object. Doesn't matter. At the current moment, we just create a test runner, just an entity which can accept some messages. After that, we can send a message to a test runner, which says run test suits. Okay. And it provides a test suite to run. And after that, the test runner decides how to run them. And for example, if it's a list of test suits, it can decide to create a separate thread for each test suite and run those test suits on those separate threads. Boom, boom, boom. And inside those threads, the test suits will be sending messages back to a test runner that the test suite started, test case started, assert, failed, test case finished, and test suite finished as well. and test runner will be reacting to it somehow. For example, updating some atomic variables or doing something like this. This one is pretty complicated. Okay, messages can be just queued. Test suit begin. We need to modify it a bit. Pass. Okay, this one looks viable. I said live coding, but we just did live commenting instead of live coding, but it's very useful already. It's just a matter of implementation. I still would like to draw it a bit on a paper or on my tablet to understand how it relates, how all the entries relates. But yeah, the idea of message passing to a test runner looks good. Now we need to decide how we start test runner when we have a separate assert executed in the REPL. Do we create a new test runner every time? Or do we reset the information that contained in this test runner? What is does when it executed on its own? Does it create a test runner and ask test runner to execute itself? This is a question about areas of responsibility of different entities. But let's keep this question for future us, because today we already did a pretty good job on diving deeper into the stuff. Yep, let's do so. I hope today's stream was useful. If you have any questions, please send them to me via comments or my emails or Fediverse. I am really glad that you joined or watching it later, and I hope you enjoyed, and I see you in a bit. Bye.